Welcome to our guide on the isolation of quercetin from yellow onion. Our journey begins with the isolation of the outer layer of the yellow onion plant. The isolated leaves were then dried at room temperature for 2 days, followed by 3 hours in an oven at 30 degrees Celsius. The isolated and now dry onion leaves were then ground into a fine powder using a household coffee grinder. This will improve the efficiency of our extraction by providing a large surface contact area between the solvent and the sample. Using a mass balance, an empty weigh boat was zeroed before adding 0.25 grams of ground onion leaf to it. We then carefully transfer the weighed onion leaf into a 15 ml centrifuge tube. Our plant material contains various constituents, including other secondary metabolites such as terpenoids, and other phenolic compounds alongside our target flavonoid. It will also contain other primary metabolites such as sugars, which are very hydrophilic. If we don't perform the extraction effectively, we run the risk of co-eluting these other constituents with our quercetin. Clearly, the choice of solvent system we use is critical. I wonder what solvent system we'll use to extract quercetin. To extract quercetin effectively, we'll use a solvent system comprising ethyl acetate methanol in the ratio 9:1. Using a graduated cylinder and pasteur pipette, 2.5 ml of the solvent is measured and transferred into the centrifuge tube containing the ground onion leaves. The lid of the centrifuge tube is closed and the mixture is vigorously shaken for 15 minutes. After 15 minutes of shaking, we perform a centrifugation step to separate out the solid material from the liquid material. After this step, we will have a clear liquid. A tube equal in weight to the sample is added to balance the centrifuge. The centrifuge is then locked and the process started. As we can see, our sample is separated into 2 layers. Our upper organic layer now contains quercetin and other non-polar compounds not of interest, which we will be able to separate when we perform flash column chromatography. Our next step is to transfer the supernatant containing our extracted quercetin into a 10 ml round bottom flask, using a pipette to cant the supernatant in, taking care not to spill any of it. With our extract ready, it is now time to remove the solvent using a rotary evaporator. We place the flask on the apparatus, ensuring the vacuum pump is switched on and a secure attachment. Put the blue clip back on and then rotate and lower the flask into the water bath. The solvent is removed relatively quickly, leaving us with a residue with a yellow colour, indicative of quercetin. We will then reconstitute our dried residue in 100 microliters of our 9:1 mixture of ethyl acetate methanol, ensuring we swirl around to solubilize all the residue. Now let's move to the separation stage using flash column chromatography. As we prepare the flash column, we pack it with cotton wool to protect the base of the column. Using a pasteur pipette, force the cotton wool down the base of the column so that it is reasonably firm. We then add sand to a depth of 0.5 centimeters on top of the cotton wool, before adding our stationary phase, flash silica normal phase. Gently tap the silica on top to compact it together, ensuring that the layer on top is kept perfectly flat. Add this to a depth of 3.5 centimeters. We will then add a layer of sand on top.
Using a micropipette, 100 microliters of the reconstituted resin was added onto the dry column and forced through the sound layer onto the silica gel stationary phase by application of positive pressure. To effect the separation, a 69 to 30 to 1 mixture of pentane ethyl acetate formic acid was added onto the column. The volume added reached the kink press on the pipette for each fraction collected. Positive pressure was applied to collect each of the 16 fractions. We will now prepare our TLC plate by drawing a horizontal line 2 cm up from the baseline and another line a further 8 cm from the line that we have drawn to indicate the development distance endpoint. We will then mark out 18 spots on the plate, 16 for our collected fractions, 1 spot for our crude sample, and 1 spot for a quercetin reference sample. We will now add 20 microliters of each of the 16 fractions to the TLC plate. We will also add 5 microliters of crude sample and 5 microliters of the reference sample onto the plate. For reference, the full volume of a capillary tube is approximately 10 microliters. We will now carefully place our prepared TLC plate into the TLC tank, which we've prepared with a solvent mixture of 68 parts pentane, 30 parts ethyl acetate and 2 parts formic acid. The solvent will move up the plate through capillary action, carrying our sample components along with it. We'll allow the plate to develop until the solvent front reaches the top line marked. Once the plate has been developed, it is then viewed under UV light at 254 nanometers. By comparing our fraction spots with that of the reference, we can conclude that fractions 8 to 12 contain quercetin. Taking a new 10ml round bottom flask and cork holder, we first stir the balance before using a pasture pipette to collect the fractions containing quercetin. We can evaporate off the solvent as before and weigh the flask again to determine the amount of quercetin isolated.
We have now successfully isolated quercetin from yellow onion.